Hello, everybody. Welcome back to the Alan Turing Room. Here to talk to you today about NeoBoard is Milton Mora. They're going to be talking about scaling the real-time aspects of NeoBoard from peer-to-peer to MatrixRTC and LiveKit. Please give them a warm round of applause.
Thank you, everyone, for taking your time to be here today. As it was announced, I'll be talking about NeoBoard and how we're scaling it. You might have heard of NeoBoard, so let's start by explaining quickly what it is. So it's a real-time collaborative whiteboard. Think Excalidraw, TLDraw, Draw.io, where people join in, do collaborative drawing or do brainstorming, just collaborate on a visual graphical interface. And this is so that was the presentation. I won't talk much about the product features. So for that, you should see Robert's talk on Thursday. So it's been evolving for the last 2 years. This started in 2023. And we had a big milestone recently where we were selected to be with the whiteboard app on OpenDesk. OpenDesk is a productivity suite based on open source applications and open source software for the German public sector. And we'll be rolling out this by the end of the year, start of next year. For all the details in what are our product features and what you can do with NeoBoard, you can check out Robert's talk. Another interesting thing is that you're actually looking at NeoBoard. So this is a presentation done using the NeoBoard widget. We have here the slides, which I will go through. So you're actually seeing the product being used in this presentation. All right, so how does it use Matrix? Quick. So initially, and the NeoBoard itself, the functional, the application part is a widget. A widget is a web application that can be hosted within a Matrix client. So in a typical deployment scenario of Matrix, you have a home server. This home server exchanges events via the client server API with a Matrix client. So on the left, you have your element web, which has a Matrix client that the JS SDK provides. You have a widget driver, and the widget exchanges these events through this widget driver to the Matrix client. And we don't worry about encryption. We get the events already unencrypted and can send unencrypted events, and the client handles all of that. And you have all of the other features that Element Web provides you, like video calling and chat. And then what we have, our latest, what we're building as a product is NeoBoard Standalone. And the architecture is very similar. So we focus on the NeoBoard, on the whiteboarding features. So it's exclusively focused on the widget running within a Matrix client and communicating via the widget driver. So because we're using the Matrix protocol, our concept for data is that a room is a data container. For each room, you have a NeoBoard. That's not like a fixed thing. Our data model supports that you can have more than one whiteboard in a room. We do support this scenario. And we keep the whiteboard configuration within custom state events in the room state. We have our own custom type, and the whiteboard contents, so the drawings and the pictures. The pictures are a different situation, but the links to the pictures are in the this document that gets stored as timeline events. Because of the event limit of 65K, we also chunk them, so you will have a version, a snapshot, a version of the document, a link to all of those pieces of the document, and then we will keep updating that as the changes in the document are being done by everyone in the room. So this is a quick overview of our event model. So specific types. On the top left, you have our state event. And then on the lower right, you have our snapshot event. So we're using the thread concept where the events are referencing each other through the relations. So we have data flowing between users. They are already collaborating, but this is not real time. So there is some latency here. But we do need real-time data. We have persistent data. So I've mentioned the document model. It gets stored in timeline events. But then we have transient data for, like, if you've seen Robert's talk, you will see pointers moving around from the other users that are joined in the session. And you also have, like, what I'm currently doing. So if I enter presentation mode and other people are in the same room and have the widget, or you're using standalone that are with the whiteboard open, they will see this transition. Some features will be hidden out. So there is this transient data that needs to be moving around, and it doesn't make sense to have them as state or timeline events. So what's the solution for that? So we have this low latency. We need a good solution for this. There's also the overhead of the event metadata, so we have around 350 bytes for each event. If you can send like much smaller packets, there's also improvement. And you also have potentially rate limiting, so stricter policies in home servers will not allow you to send updates rapidly. So how did we approach this? So we look at what was being done with element call and MSC 3401 at the time. This is late 2023, early 2024. And WebRTC is the standard web technology for peer streaming of media, also data. So we followed the lead from element and element call and the MSC to implement this. So how does it work? We discovered the active participants. So we have a custom state event that manages the sessions. So the equivalent to m.call in the initial MSC. Then you have your own state event tied to your MX ID, and we just we keep a list of sessions for your device or your devices, and the client itself will manage that. So there's an issue here for expired sessions. So if the browser is closed, we would not have a way to quickly remove that session. So you might be attempting to connect to peers that would not be there already. So there was some drawbacks to this. And also the issue that you have to establish an n-1 data channel. So if you have 20 people in a room or in a whiteboard session, you will be trying to connect to 19 other peers through turn and stun. And the process here is also a bit complicated. You have to get through the WebRTC API the routing information for these peers and hope that you can connect to them. We were distributing these candidates with 2-device messages because they're not non-persistent, but also have reliable delivery. So as the peers were establishing these connections, some were reachable, some were not. And this was architected in a way that we have a real-time layer that's pretty, let's say, flexible. We had this whiteboard instance, which has a session manager and goes through those state events to get an understanding of who is currently collaborating on a whiteboard. Then the actual synchronization of data is tied to this synchronized document, which is using a communication channel that is managing all of these peer connections. So in a high-level overview, that's what we had at the time. But this wasn't working very well. So realistically, stun only works for 75% of online devices. This is the metrics I could find as a reference, but in our testing, it wouldn't really be that high. And then for the relaying part of data, when you can't access directly the device through the NAT or other issues in routing, you use relaying, but then setting up a relay server is just another infrastructure complexity. You need considerable bandwidth, and if you use a public server, then it gets even more complicated with quota limitations. So it really doesn't scale up. Even Chrome as a browser has 500 peers hard limit. And the client needs to handle this full mesh set of connections. So sometime later, because element call was also having similar issues, and because Matrix is using real-time communications in other use cases, like third room, and also NeoBoard was a good example of this, beyond element call. The MatrixRTC set out to define a more let's say, configurable spec or extensible spec. And this defines membership state that is not specific to calling. So you could define new types of applications, have them with specific metadata, and also pluggable RTC backends. So you aren't really tied to full mesh. And they brought in the SFU approach. So this is sort of obsolete, so I had to change the slides from this week on because of the recent changes. So I'll be marking here there what's not really the current status of RTC. This is from early 2025. So what changed in NeoBoard with this new approach? So essentially, we moved from the custom membership, session membership state, which was keeping all of the sessions in a single custom state event, and we used the new RTC member, session membership state approach. So this was one of the main change, how we manage sessions. Obviously, the backend also something that we changed, so going from full mesh to SFU. And in practice, in the components of the actual application, this means we have now two pluggable session managers, one from WebRTC, the other from MatrixRTC. In the case of the session manager, it was extended with a few more features because of the handling of the focus discovery and focus selection. Then on the communications channel side, it really didn't change much because the semantics change a bit, because if you don't have available SFU, you can't connect to this real-time channel. In the other scenario, you could be connected like to half or some of the peers, like a subset of the peers. So we now have to have a stricter handling of what's the actual connectivity to this backend. And finally, the last change is a minor change. So each peer connection, so we don't have a pool of peers. We have one peer, which is a LiveKit client that keeps two LiveKit connections, one for publishing data and one for receiving. So yeah, positive aspects, simpler implementation, reliable real-time connections, and greater scalability. Not so positive, so more complex deployments with LiveKit and the WebRTC auth service, but I think that's becoming standard, so not really a problem. And also, yeah, we got a bit bitten by not using the RTC membership logic from the JS SDK, because now things have changed and we have to re-implement some part of this. I'll go to that in a minute. Challenges. So we have a different semantics in NeoBoard. So we don't have a ringing, we don't reject calls, we don't have some of the telephony use cases. People just join and leave a whiteboard. What happens if you don't explicitly leave? So if you close the browser, delayed events came to answer this, also for element call and hanging up. So yeah, delayed events work in a way that you send an event, a disconnecting event or a quitting session termination event to the home server. It doesn't get applied to the actual DAG or to room DAG. It stays there lingering until it expires. The app is responsible for resetting that expiry timer, and if you close the app, then the event gets sent and you are out of that real-time session. There are some scalability issues with this we discovered recently with our friends from Medio. So yeah, take this with care if you're planning on using this for a production solution. The other issue that we soon found is that if you want to have multiple RTC apps as widgets in the same room, because of the way state keys for the state events were being implemented, you would not be able to do that. There was this proposal to extend the state key with an application identifier, which sort of mitigates that. But this is all going away because of sticky events and slots. So this is what we have now, but we'll have to rework it because it's no longer the proposed approach. So everything works. It's working. It's great. Now what? The journey continues because we haven't really reached the final point, because just recently, this last month, there were a lot of changes in the MatrixRTC spec with the concept of slots, sticky events, and the multi-SFU. We also need to do an MSC for the actual whiteboard application type, something that we want to specify. And I've also been seen around throwing the idea of having WebSockets as an RTC transport or RTC backend, which would make it a lot easier for us because we don't do media, we just send out data packets. So it's a bit of an overhead to have a LiveKit SFU when we don't do full media. Yeah, I think that's it. I'm on time? Good. Thank you. Questions?
Yes. Any questions, please raise your hand.
Oh, thank you. We talk really accessible, really understandable. Just one small question.
Sure.
The delayed events mechanism is basically like a deadman switch?
I think so.
Okay.
Yeah, I'm not familiar with the concept, but yeah.
Yeah, I actually wrote a note after you mentioned delayed events thinking, I could actually implement a deadman switch on this, but sticky events are the way forward.
Yeah.
I mean, you could, it depends. Use cases.
How do you control the frequency of persisting the RTC data, well, the updates to the matrix room? Like, how do you manage synchronization issues there?
So we're using a CRDT data model. So we have it in a cache where we append to that document, and periodically that gets snapshotted and sent to the timeline. And we only exchange the CRDT deltas in the real-time communication.
So that's always growing every time it snapshots. So
yes,
it's like unbounded growth there.
Yeah, but our idea is to eventually remove the actual binary content from the timeline and just use media store for that and keep the MXC to the actual document data there. So that's our goal.
Any more questions?
Sorry. Now that CRDTs were mentioned, are you using some well-known implementation, CRDT implementation, or your own custom hand-rolled one?
Hand-rolled, sorry?
Like, are you using some well-known CRDT implementation, or is it just fully custom?
CRDT YJS, yes. We are using YJS library.
All right, if there's no more questions, please, another round of applause.
Thank you.